Good afternoon, everybody. I'm Narain Hariharan with Graymont. Been with Graymont for about 5 years. My background is in civil engineering and got my civil engineering from Texas A&M University. And right now, working for Graymont in the marketing team as new products and applications manager, developing low carbon cementitious products for the construction applications. So happy to be here. Today I'm going to be talking about the low carbon cementitious binder for soil mixing applications. It's a new product line that's launched by Graymont, which we call Graybond. So we're not calling it a product, but a family of products under the label of Graybond, which is a lime-based cementitious solution. So what is in Graybond? So just to take a step back for those of you that may not be aware about Graymont, Graymont's a world leader in lime and limestone solutions. So we have operations in North America, both US, Canada, and also in Asia Pacific, Australia, New Zealand, Malaysia, and the Philippines. So our strength is the manufacturing of quicklime, hydrated lime, and limestone fines. We're building on our strengths and expanding the range of our products that we offer for construction and mining applications by integrating what we know we can do in terms of lime and limestone and combining it with well-established concepts and including pozzolans, natural pozzolans or pozzollanically active raw materials. And you can think of any source that has a reactive source of alumina and silica. So combining them, blending them in optimal proportions based on the end application, and milling them in a ball mill to optimal sizes results in the formation of the Graybond product for different applications. So specifically for soils, Graybond is a patented solution. We like to say it's a customizable solution based on the soil type and the application. So we're able to adjust our blend ratios to tailor our product to be suitable for different types of soils. We're looking into two aspects within soil treatment. Obviously, the superficial soil treatment, which is more the subgrades that you see below the pavement. That is where lime has an established use to treat clays, and the concept of introducing Graybond is to broaden the type of soils that we can treat using lime-based solutions. Deep soil mixing is one where cement is typically the default binder, and lime has been used in the Scandinavian countries somewhat to treat clays. It's less prevalent in North America, but we are working with industry partners to see how we can utilize lime-based solutions to optimize the binder application rates and also the binder consumption while lowering the greenhouse gas footprint. So deep soil mixing, we've done some case studies with Keller at a lab scale, along with Thurber in Edmonton in Canada. So we'll touch on that a little bit in the slides to come. So those are the two main types of applications we're looking at in terms of soil treatment for Graybond. So in terms of the cement, in terms of how Graybond works, it can either be a standalone binder depending on the soil type, or can be used with cement to replace a portion of the cement. And the global warming potential, or the GHG carbon footprint of Graybond, is between 0.3 and 0.5 kilograms per kilogram of binder. It'll obviously, the range is, I've provided a range because the carbon footprint will vary depending on the amount of lime that's used relative to the amount of pozzolan. So suitable soil types. As you can see here, lime is typically used for clays, PI of above 10 and 50, the lean clays and the highly plastic clays is where lime is the preferred binder. For Graybond, we're looking at more of the sandy sills, sandy clays, the silty clays, and more of the lower plasticity soils ranging between 6 and 25. Fine grained soils, obviously, and the ratio of lime and limestone fines to pozzolan will be higher as the clay content increases. So we've done quite a few third-party lab studies over the past 3 to 4 years in California, in Western Canada, in the Central region in Michigan, and also some in Eastern Canada. I'm just presenting an example here. So in this instance, the soils were silty sand with clays, about PI of about 16. We went in with a Graybond blend ratio of 30% quicklime, 50% pozzolans, and finally pulverized limestone fines, 20%. So the sizing of the limestone fines is top size of 45 micron. The binder application rate was 4%, and we compared the performance of Graybond against cement. In this instance, it was a 100% replacement of the cement, and we observed consistent increase in strength. We got strengths of about upwards of 4 megapascals for those of you familiar with, more in tune with the MPAs. So we also saw the benefits of the increase in early strength and also the durability in terms of the longer strength gain. So longer term strength gain. So again, this is not to say that it's a one size fit all solution. Every project and soil type is going to be different. So the attitude that we come up with is to make sure that we customize the product and handle it on a case-by-case basis, making sure that we're able to provide the right solution based on the soil type. We also did our first field trial in Utah with the support of a soil stabilization contractor. In this instance, the PI of the soils was 22. Obviously, you can see that the lime to pozzolan blend ratio was slightly higher because of the higher clay content, so 55% lime in there and 35% pozzolans. We did a comparison between the 4% and 5% binder application rate, which equates to about 125 to 150 kilograms per meter cube of grout. We again saw very comparable strength results to cement, both early age and the day 28. We were able to hit the 1.2 megapascal strength target within the day 28, and we also noticed some interesting trends that were in. We learned a couple of things where more binder is not always better. We need to make sure that we spend the time and effort to identify the right binder content to stabilize soils. And we also saw some opportunities to lower cost and lower the carbon footprint by optimizing the use of the binders, wherein you notice here that a 4% Graybond actually performs equally well compared to a 5% cement. That's not to say that, again, it's going to happen every time, but it's an instance where the right amount of binder and the right choice of binder can go a long way towards reducing costs and binder use. So the fundamental mechanism of how Graybond works is twofold. Obviously, you have the lime that activates the clays, increases the pH of the soils, provides the source of calcium to react with the amorphous alumina silica, the solubilizing the alumina silica in the clays and reacting with the calcium with the high pH to form calcium alumina silicates and cementitious products. That's one mechanism. The other is the reaction between the lime and the pozzolans, wherein the lime also activates the pozzolans and builds strengths on its own. So it's a combination of converting in situ materials into cementitious products and also converting the pozzolans into cementitious phases. So similar in concept to what was used by the Romans to build the Roman pantheons back in the day, where pozzolans were combined with lime and has resulted in extremely durable and strong lasting structures. So very similar in concept and chemical makeup to cement, but an engineered binder where we can optimize and make sure that we have a consistent chemical composition. So just some of the key benefits and value proposition for Graybond revolves obviously around the carbon footprint and the performance of the binder, replacing 35% or more of the cement in most cases, and the distinguishing between Graybond and some of the other SCMs is Graybond's not a byproduct, but it's an engineered product where we have tight control over the quality of the product and the chemical composition. We also build on Graymont's strong supply and logistics capabilities. We're working on scaling up and opening 3 production facilities in North America in 2025. One in the central region in Michigan, one in eastern Canada, and one in the west in Washington. And just to give a snapshot on how Graymont has evolved over time, we started out in 2021, so it's been about 4 years since we started the development of the product. We closely engaged with several third-party engineering firms, to build credibility and also to gain exposure to different types of soils. We have done studies, like I mentioned, with Keller and Thurber, with NGO in California, with different types of clays, just to build our understanding on defining the right composition of the binder for different soil types. And we also introduced Graybond to the North American audience at CalGeo earlier this year, to primarily the audience in the west of North America. And we have also done our field trials in April, and we are also we're actively doing other trials in other parts of the US with partnership with soil stabilization contractors. So, and as I said, commercial production, we're looking at about 50,000 tons, upwards of 50,000 tons at each of our 3 production facilities beginning in Q1. The first plant will be in Superior, Michigan, and then we'll towards the second half of next year, we'll open up in Eastern Canada and Western US. So that's my presentation today. Feel free to reach out to me after the session, and also email us at graybond@graymont.com to learn more, and I'll be happy to discuss about your needs. So thank you.
Anybody have any questions for Narain?
What is the range of water cement ratio that you are working with?
Yeah. So so the water cement ratio will vary on two aspects. One is obviously you want to, in certain instances, you want to make sure that you're achieving the maximum dry density of the soils. Comparing to cement, if we are to compare it with cement, we're slightly higher water cement ratio because the pozzolans have a slight higher water demand. But yeah, so we're looking at a slightly higher water binder ratio, and you need the sufficient water to form the hydration products when combined with lime and pozzolan. So yeah.
Any other questions? All right, thank you, Narain.
Thank you, Steve.